Problem 122, we're taking a look at several different problems. They're all going to become logarithm type problems, but there's also relationships here that I'm going to go over. So if we take a look at the very first one, I'm solving for the exponent. So that means I'm going to be using the power property of log. So I have 27 equals 6 to the x. What I'm going to do is take the log of both sides. And when I do that, what that allows me to do is take my exponent and move it out front using that power property that I had mentioned. So this problem now becomes x times the log of 6 equals the log of 27. And to solve for x, I'm going to divide by the log of 6 on both sides. There's my giant 1. So now x equals, use my calculator to put that in, and that is to 3 decimal places. They want 3 decimal places in this problem. 1.839. So that is for problem A. Problem B. There's going to be multiple ways you could do problem B. So whatever I go over here might be different from maybe what you were thinking to do yourself, but this is one option. This is 27 over 1. So now that I have a proportion here, since I have the 6x in the denominator, what I could just do is use the reciprocal of both sides. So you can do that if we have a proportion here. So if I take the reciprocal of both sides, I'm going to end up getting 1 over 27 equals 6 to the x over 1, or just 6 to the x. Now I would get the same thing if I would cross multiply, and then I would divide by 27. So if I would cross multiply, I would get 27 times 6 to the x equals 1, and then I would divide by 27, and that would give me again 1/27 equals 6 to the x. So either way you want to get to this point, it doesn't make a difference. Nonetheless, here's where I am. So now what I'm going to do is once again do logarithms. So log and log. I'm going to follow the same steps as before. So I'm going to get x times log of 6 equals the log of 1 over 27. Divide then by a log of 6. Giant 1 here. Put that in the calculator, and this time x equals a negative 1.839. So why that makes sense here is, remember that a negative exponent basically just moves something to its reciprocal. So if I have a negative exponent in the denominator, it would move it to the numerator and become a positive exponent. So if I have, for this problem, 1 over 6 to the x, if my exponent is negative, that means, so if this is, we know this right now, it's a negative 1.839. To make that a positive exponent, it goes to the numerator and becomes 6 to the 1.839, which is now the exact same as problem A. So that's why these two are the same number, just opposites. One's positive, one's negative. So problem C, we could go through and do a lot of the same things that we did in the last two problems. Or if I think of what this is now, right now x to the 1/6. So if I want to make that a positive, or switch the sign for whatever this was. So if I made that a negative x, this gets moved to the numerator, and it becomes 1/6 to the negative x, whatever that x value is. And then if I want to switch this to its reciprocal, I make that once again now positive, and I'm going to get 6 to the positive x. So this problem here actually turns into the exact same thing as problem A. Again, just by using negative exponent things. If you wanted to go through and solve it just like we did the previous problems, you can. But this is going to be the exact same as problem A. So x equals 1.839. So again, using our negative exponent laws on that one. That then is the exact same idea as problem D. So a couple things we could do here. Going more in depth with problem C, I guess, is explaining this part. So if I think of my denominator, 1 over 6 to the x, that is 1 to the x over 6 to the x. That's just the denominator. Well, 1 to the x just equals 1, so this is 1 over 6 to the x. So when I think of this fraction now, I have 1 divided by 1 over 6 to the x. Instead of dividing by a fraction, I am going to take my numerator and multiply by its reciprocal, 6 to the x over 1. And that just is 6 to the x. So again, that's proving that's that, and also why that one is the same as problem A.